A solution contains silver and mercury ions. The addition of 0.1 liter of a 1.22 molar sodium iodide solution is just enough to precipitate all the ions and form silver iodide and mercury 2 iodide. The total mass of the precipitate is 28.1 grams. Find the mass of silver iodide in the reaction. Okay, so basically we have two reactions and we know the total mass that these two precipitates contain of and what was used in the reaction to form them. So I know that I have the mass of silver iodide and mercury iodide, which is equal to 28.1 grams. So I know that. Well, I know that I can find the molar masses of both, so I'm just immediately going to assume X is silver iodide and Y is mercury 2 iodide. So X plus Y is equal to 28.1. Well, I don't know the amount of mass I have, but I know that I can use molar mass eventually to get to mass. So I'm going to place in here 234.77x plus 454.39y is equal to 28.1. So I plugged in molar masses of silver iodide and mercury 2 iodide. The reason I did that is because I can already see that I'm given a piece of the information, and I know that molarity, is moles over liter. And I know that I want grams. And I'll be given an equation. So to me, it always makes the most sense to plug in molar mass because you can usually always find something with moles and cancel out your equation. So I have this equation given that I created. Well, I'm going to need to use that other piece of information. I know that sodium iodide was used in both of these reactions to make the precipitate. So I can figure out the amount of moles of iodide in the solution. So 0.1 liter times 1.22 moles over liter times I have 1 mole of the iodide ion in the total solution gives me 0.122 mole of iodine. So now I have the total. So then I can set up the same kind of equation and say that I have X plus Y is equal to 0.122 moles of iodine. Since I know iodide made both precipitates. Therefore, I can say that X, silver iodide, and Y, mercury iodide, is this many moles, total moles. Then you can just isolate for one variable, doesn't matter which one. And then go back to your original equation, plug in for X, which will look like this. 234.77 times 0.122 minus Y plus 454.39y is equal to 28.1. Then you expand that. 28.64194 minus, this is 2y, minus 469.54y plus 454.39y is equal to 28.1. And that gives you negative 15.15y is equal to negative 0.54194, and then y is equal to 0.03577. Then solve for x. We know that we said that x is equal to 0.122 minus 2y. You plug in what you got for y, which is equal to 0.05046 moles. And then find mass. Since we just found the moles, 0.05046 times the molar mass will then give you 11.846 grams. You want 3 significant figures if you go back to your problem, so therefore 11.8 grams of silver iodide was formed. So you're given that you have a total mass of 28.1, that is the total precipitate, and 2 precipitates formed, silver iodide and mercury 2 iodide. They formed because a solution that had these ions in them added 0.1 liters of 1.22 molars of sodium iodide. So then you also know that you can find the moles of iodide, and that pertain to the moles of silver and mercury in the solution. So I set up an equation saying that the mass of silver iodide and mass of mercury 2 iodide is equal to the total mass. Keep it a little bit simpler. Said that X is silver iodide and Y is mercury 2 iodide. Knowing that you can use molar mass to find grams, I plugged in the molar masses since I don't know the mass of these 2 products. Then I figured out, all right, well, I know that iodide is in both of these, so I can use the information from sodium iodide. Knowing that sodium iodide was in the reaction and sodium is a spectator ion, does not pertain to the precipitates formed, but iodine does. I isolated for iodine moles from the molarity and the volume. Then knew that, all right, since I have this many moles of iodines, and I have 2 moles of iodines in the reaction for mercury, 1 mole for silver, X plus Y will be this many total moles of iodine in my reaction that helped form my precipitates. Isolated for a variable, and then it just becomes back to algebra and plugging it into my mass equation from above. Solved for my Y, plugged that back into X because I cared about silver, and then found the moles of silver iodide, used the molar mass to find the grams.